All right, guys, we're going to give everybody a few more minutes and then we'll get started.
Well,
Okay, can you guys all hear me? Yes? Someone shake their head. Okay, awesome, thank you. Just want to make sure. Okay, I'm just gonna break down this week for you guys really quick. I know I said that I would have the exams graded, okay? I have looked through all of them and done the calculations and everything, but I am just waiting for the answer key from Professor Stone to make sure that I myself didn't make any errors on the test. Okay, so then I should hopefully have these back to you guys by Wednesday. Okay, once we have all the tests, I will put the test into Blackboard for you guys. I will add your little notes there, and then I will actually give you back your physical copies when we are in class together. So just bear with me a little bit. Hopefully I have them for you by Wednesday, and then we will go over it all in a class if we need to. Okay, speaking in terms of this week and how it's gonna go, we're gonna go through a lecture today. Okay, it's not that long of a lecture. It's not any information that's totally going to like kill your guys' brain. But we'll go through the lecture today. Wednesday, we will be online, so do not show up in class. Okay, so make sure you guys write that down. I will send you an announcement as well. We will start our lab online this week and go through stuff. Next Monday, we will be in class, okay? Again, I will send you guys an update for all of this. But for this week, we're still online, going to go over part of the lab on Wednesday online, and then we will finish the lab in person next Monday. Okay, so you guys have to think to yourself that you need to be on campus on Monday. Again, if anything comes up, someone doesn't feel comfortable, something along those lines, make sure you guys let me know, okay? We will work with all of you on this, okay? Any questions moving forward with anything? Okay, reminders that you guys need to be turning in your labs this week, okay? They are due this week by Wednesday, I believe, or Thursday. I can't remember exactly, I don't have the due date in front of me. I'll send you an announcement. But let's make sure we get those in so you guys get the full points, okay? I don't wanna give anybody, dock anybody on points just because you guys aren't getting anything in, okay? If you ever have questions on it, just ask me, okay? That whole long spiel, sorry. Okay, let's jump right into our lecture. Okay, if you guys have questions at any time, just stop me. Okay, so what we were talking about today is body composition assessment. There's a lot of different ways to do it. We're kind of going to go over all of it, but we will only be using certain ones in class because we only have means to certain types of equipment. Okay, so terms that you guys need to know for all of this. Okay, so we have total body weight. That is going to be your body weight with everything in your body. So we're talking fat, water, bone, muscle, connective tissue, organs, everything. That's your total body weight. Okay, pretty self-explanatory. All right, your fat mass, okay, is going to be your body tissue that's made up just of fat. So that fat is going to include your subcutaneous fat, which is right underneath the layer of your skin. So what you guys can feel on your actual skin, that's subcutaneous fat. It's not necessarily bad for you. Okay, it's not the fat that's going to go into your arteries, things of that nature. Okay, it's also needed on your body for protection, things of that nature. Okay, another fat included in fat mass would be your visceral fat. That is going to be the fat that is dangerous. Okay, this fat can lead to clogged arteries, things of that nature, and this is also the fat that you would see in the abdominal area. Okay, so around our abdominal area, we have all our organs, things of that nature. If we have too much fat, it presses on the organs and can cause a lot of issues like that. Cellular membranes are also included in fat mass. So you have subcutaneous fat, visceral fat, cellular membranes. Okay, so that is what's considered your fat mass. Your fat-free mass is all body tissues that are not fat. So body tissues including bone, muscle, organs, connective tissues. Okay, so that's your fat-free mass. A lot of that times it's also called lean body mass. So if you see LBM, it's basically the same as fat-free mass. We are going to be calling it fat-free mass in this class, but you might see it denoted as lean body mass in other publications and things of that nature. Okay, moving right along. Okay, so common measurements for measuring fat, weight, things of that nature. So there's going to be things like some circumference measurements we'll go into, using a tape measure to measure certain parts of your body, underwater weighing, skin fold measurements, body mass index, waist to hip ratio. So in this class, we will be focusing on circumference measurements, skin fold measurements, BMI, and waist to hip ratio. So this is what our labs are going to entail on, okay? I will break this all down further in the slides as well, okay? So how you assess risk of your disease, or risk of disease, okay? So we've been talking about risk of disease. We talked about this in the last unit as well. You are gonna use circumference measurements, BMI, and waist to hip ratio to assess your risk of the disease, okay? The National Institute of Health puts out publications, and that's we'll be giving you guys those charts as well, okay? It has all of the ranges that everyone should be in for circumference measurements, body mass index, and waist to hip ratio. So these are 3 ways that we help to assess the risk with an individual client, okay? So once we've done that, you can also use this to set goals. So if you have, whether it be a personal training client, whether it be someone who is just trying to lose weight for heart health, anything along those lines, okay, you can use all these measurements to figure out their desired body weight, okay, their lean body mass, their true body weight, and their fat mass. Don't worry about these equations right now. We will get into it a little bit later, but it's just, I want you guys to think that it is a form of goal setting as well, okay? So you can use these measurements as goal setting, okay? Realistic fat loss, okay? This comes up a lot. There literally is no such thing as zero body fat, okay? You need fat to live, okay? So fat is essential for your life. So it gives your body energy, okay? One of the things that you guys have all should have learned about, okay, in the energy systems of the body, you are using fat, okay? It also helps protect your organs, okay? So we talked about the fat around your organs. It helps keep you warm, okay? And there are also, it makes up your cellular membranes, okay? So those are the membranes around the cells in your body. It helps with fat-soluble vitamins. So think of vitamins A, D, E, and K, okay? You need fat in order to absorb those vitamins. Without fat, you cannot do that. And very importantly, fat helps make up parts of the nervous system. So that helps make up nerves and your brain. So you absolutely 100% need fat, okay? Obviously, you don't want fat in excess, but you need to have fat. There's no such thing as 0% body fat. So if you guys are ever listening to those people that are like, or a woman is saying that she needs to have 6% body fat, it's not realistic, okay? You need fat to function, all right? So another aspect of that, you have things called essential fats in your body, okay? Essential fats are needed to live. These cannot be burned off. So essential fats are things like omega-3 acids. So if you ever looked at, you can find that in fish, okay? You also have your omega-6 fatty acids, which is like polyunsaturated fats found in nuts, seeds, things of that nature, okay? So the essential fats are needed for biological things to happen within your body. So for men, you need to have up to 3% of their essential fat is 3% of their fat mass, okay, in men. It can range anywhere from 2 to 5, but the average is 3%. Okay, essential fat in women is up to 12% of their fat mass within their entire body. So you can see that women obviously carry a little bit more fat. A lot of that is necessary to just biological terms in your body and the fact that women give birth, okay? So you have to remember essential fat cannot be burned. 3% of fat mass in men is essential fat and 12% in fat mass in women is essential fat, okay? Any questions thus far? All right, cool. Let's move on. Okay, so we have body composition models, okay, and there will be a slide on this, but there's models that have 2 components, there's models that have 3 components, but 2 component models basically split the body into fat mass and free fat mass, okay? And then we have underwater weighing, which we'll talk about, and then our skin fold thickness goes into the 2 component model, okay? So, and then we also have multi-component models. Okay, so this is going to be anywhere from 3 to 4 components. It's going to split the body into fat mass and free fat mass, okay? And then it splits the free fat mass, okay, in the fat-free mass, I'm sorry, in your body, okay? So it not only just splits it here, then it's going to split the free fatty mass in your body, okay? So this is just an example of it, okay? So we have, let me move this out of my screen. Okay, so we have the 2 component model here. So we just have fat mass and fat-free mass, okay? That's pretty standard for what we're gonna have. We have a 3 component model, okay? So we have fat mass, and then remember it breaks up the fat-free mass, so bone is also included in that fat-free mass. Another 3 component model would be your fat mass, and then you break up that fat-free mass, which you have fat-free mass of muscle, or I'm sorry, of protein and bone, protein, which would be your muscle, and then water. And then we continue to break it down even further. So if we are talking in terms of how this should be, obviously the components that are, or 3 component, 4 component, 5 component models are going to be a lot more accurate, okay, than just a 2 component model, okay? However, a lot of the times within labs and means of your equipment, a lot of the times we're only gonna be able to use 2 component models, which is totally fine and accurate enough unless you're in that clinical setting and you really need these larger component models, okay? Any questions on the different types of models? Nope, okay. I feel like I'm talking kind of fast today, so if I am, just stop me if you guys have any questions. Okay, so body composition models. So we talked about the multi-component models, and we will break every single one of these down. So don't worry about it right now, but I'm sure you guys have all heard about them. So multi-component models. So now we're talking 3, 4, 5 component models contain or DEXA scans, MRIs, bioelectrical impedance scales, and in-body scans. Okay, so multi-component models, like I said, they're definitely more accurate and precise, okay? They have a higher validity and higher reliability. And if you guys remember from the first unit, you need both of these for a test to be accurate, okay? So you need the validity, you need the reliability, okay? The more components you have, the more accurate and precise that test is going to be. Pretty self-explanatory. Okay. However, just using a scale alone, which is a lot of what we're going to do in this class, is pretty simple. Okay. It is reliable when it is calibrated and maintained. And I will describe what it means to be calibrated and maintained and send you guys videos. And we will go over this more next Monday when we are actually in class. Okay. However, it is not valid for measuring your fat mass. So if you just use a scale, all it's doing is measuring your actual weight. It is not telling you how much fat you have in your body, how much lean body mass you have in your body, how much your bones weight, anything along that. So it is just telling you combined how much that you weigh, okay? Still can use it to find things, but it's not going to be as accurate as those multi-component models, okay? All right, so then when we look into field methods, and this is what we are going to be doing in class, okay? So we are going to go to body mass index. I'm sure you guys have all heard what this stands for. So body mass index, you guys can also see it written as BMI. Okay, so I'll probably refer to it as BMI. I don't know if you guys have gone to the doctor and they've given you your BMI. It's something that they basically give everybody. Okay, so it is your height, or I'm sorry, it is your weight to height ratio. Okay, so it has a positive relationship with fat mass. So as your height, weight to height ratio goes up, your fat mass goes up. So that's what we mean by that positive relationship. Okay. So National Institute of Health has used the actual BMI to create definitions for other forms of testing as well. Okay. Most of the time, body mass index is used for overweight obesity purposes. Okay. And we'll go into, go into why in a second, okay? But as your body mass index goes up, your risk of diabetes and hypertension goes up threefold. So think about it. It's not just going up a little bit, it's tripling, okay? Your risk of hypercholesterolemia, which is high blood cholesterol, goes up ×2, okay? So as that BMI starts to rise, all of the risk of diseases like diabetes, hypertension, high blood cholesterol increase dramatically, okay? So for your BMI, hold on a second. Your BMI is helpful when used with inactive individuals. So if we think about this, we were just talking about how everybody has used BMI. Because it is used mostly as a test or indication of overweight or obesity, so think about it. It's helpful for individuals that are inactive. If we have active individuals, okay, there's going to be other things that come into play, and I'll go over that down here. It is a simple and reliable way to test body fat, okay? And it is valid for obesity risk like we've just talked about. I think I said that about 5 times already. So we're coming down to this part right here. It's not reliable for large muscular athletes, okay? So we talked about, so your fat-free mass includes bone and muscle, okay? The stronger you are, the more muscle you would technically have in your body, and muscle weighs more than fat, okay? So we cannot just use it for a muscular athlete or anybody that is just tall, things of that nature. So we need to make sure that this is more so used for obesity risk, overweight risk, okay? I think I told you guys, like one of the first lectures, like I'm 5'10", I weigh about 165 pounds. I've been an athlete all my life. My BMI is high, okay? According to the chart, I'm pretty sure they say that I'm overweight, okay? So that just goes to show that you have to take bone and muscle into consideration when you're talking about athletes or larger individuals of that nature, okay? Questions on this at all as we move forward? Nope. All right, cool. Okay, so your body mass index equation, and you guys will be using this, and we'll go over this on Wednesday and then obviously continue that into next Monday. But your BMI is your weight in kilograms divided by your height in meters squared. Very, very simple. That's what you would use to calculate your BMI. So obviously you need to know your weight, you need to know your height, and you just divide your weight by your height. That gives you your BMI. Then I'll give you guys a chart and you can see where that BMI actually falls in terms of the national ratings, okay? So pretty simple. All right, so moving along to circumference measurements, okay? So it's obviously another health risk assessment, okay? So if we're talking about it, we're using waist to hip ratio. So we will also use this, and I'll take you guys through how to do this. So basically it's just your waist in centimeters divided by your hip circumference in centimeters, okay? The thing that you guys need to remember, when we do these measurements, we're gonna get them in inches, and we're going to need to convert them to centimeters, okay? So 1 inch is 2.54 centimeters, okay? So you would just multiply inches by 2.54 centimeters to get centimeters, okay? So it's going to be waist circumference divided by your hip circumference, and I'll go into exactly what that is as well, okay? As your waist to hip ratio goes up, your risk of cardiovascular disease, things of that nature goes up. So if we look here, anything greater than 0.9 for males and anything greater than 0.8 for females, your risk of heart disease, obesity, cardiovascular disease, anything along those lines goes up. It goes up twofold. So just like we were talking about the BMI ratings, it doesn't just go up a little bit. As it continues to rise, it's got that positive correlation. As the circumference measurements rise, the risk of heart disease rises, okay? So if we are looking here, okay, at our hip to waist ratio, okay, so when we are gonna be, next week we'll go over this, okay, and on Monday you guys will all actually get a tape measure, okay, and we will be learning how to do our measurements, okay? There's a couple tricks to the trade. We don't have to go over them necessarily this second, okay, but this is where your waist measurement will be, okay, so it's right below your ribs, above your navel, and then your hip measurements are going to be around the largest part of your glutes, okay? So just remember where those two sites are that are gonna go into waist to hip ratio, okay? Questions thus far? Nope, okay. Kind of like what we talked about, so circumference measurements, they assess risks of things like heart attack, stroke, hypertension. If we are looking at overweight, obesity, things of that nature, if you are obese or you are overweight, your risk of disease goes up because you have a higher risk of a lot of comorbidities such as heart disease, stroke, hypertension, okay? So you have more fat you have in your body, the higher risk you are at these items, okay? Also diabetes, gallbladder issue, and obviously death, which could come from diabetes, all those heart disease, stroke, hypertension, all those types of diseases, okay? Skin fold thickness, okay? So this is another measure or another thing that we are gonna practice in class and you guys will have a lab on, okay? It's minimal equipment is required. It's relatively easy to do, but it also depends on the skill of the clinician. Okay, so this is why this takes practice. So you're going to use a little caliber. I don't have a picture of it, but you guys will learn about it on Wednesday. It's something that actually pinches your skin. Okay, it's not the most accurate if you get cheaper ones. Okay, and you also have to make sure that you see that it is calibrated and still in the right part. So if we can, like, obviously if you spend a little bit more money, you can probably get a little bit better equipment. But if you do not know exactly where you need to pinch the skin and certain areas of the body, how to actually administer this, you can have a lot of error in it. So if you see, you can have about 3.5% in either direction of error. Also, this is a pretty invasive type of measurement, okay? Some clients are not going to feel comfortable with you literally pinching their skin. So this is also something that you need to take into consideration with this as well, okay? But we will go over all of this a little bit more on Wednesday, okay? There are also clinical methods. Clinical methods are not what we are going to be doing. Obviously, we don't have means to the equipment, but you should be familiar with how these things work, okay? So we have underwater weighing, okay, which is called hydrostatic weighing. I don't know if you guys have ever seen this. I'll send you videos on it. You literally put a person in a pod in water and they go under and they float, okay? So the point of this is that fat is more dense than water, okay, so it should sink, and is less dense than water, so it should sink, and muscle is more dense than water, so it should float. So obviously the more muscular someone is, the more fat-free mass they have, the more that they should actually float in the water, okay? This is not easy to do. Not all people want to be underwater, okay? And it needs to be administered properly, so it depends on the clinician and someone telling you how to do it. I have seen people go underwater and actually freak out while they're doing it. So the measurements really aren't as accurate. So this is also a pretty invasive procedure as well that takes a lot from the person that's actually getting tested. Okay. Just a couple more things on it. You can compare the weight above and below water, okay? And then you get the difference of it to get your fat mass, okay? So again, we won't actually be doing it, but this is how underwater weighing works, all right? We have bioelectrical impedance analysis. I don't know if you guys have ever seen those machines that you hold in front of you and you put your wrists around it, or you can stand on a machine, and it sends very, very low electrical signals through your body. So the theory is that the electrical currents will move through muscle a lot easier than it will move through fat. So this is the theory on this. These are not invasive at all. Anybody can actually do it, but there are a lot of things that you have to do before this test to actually make sure that it is accurate, okay? I will send you a video of how it works, okay? So it estimates the total water that is in your body, okay? It also estimates your hydration state and the moisture that is in your skin, okay? So a lot of things are gonna be taken into effect with this. In order for this to be the most accurate, and I don't know if you guys have ever been into a gym, but a lot of personal trainers use this bioelectrical impedance analysis, and it's going to have very, very large errors in it because they do not ask their clients to actually do what you need to do before this. So in order for this to be accurate, you technically should not be eating or drinking 4 hours prior to this test, okay? No exercises or no exercise at all for 12 hours prior, no alcohol 48 hours prior, and no blood pressure medications. Blood pressure medications tend to dehydrate you. So a lot of people that take blood pressure medications need to take a diuretic. So that is going to goof with the results of this test. So even though this is an easy test to administer, okay, in order for this to be accurate, you need to really be on your clients and make sure that they are not eating or drinking, exercising, no alcohol, things like that prior to this actual exam. And I can tell you a lot of people don't follow that. And you are also at liberty to trust what your client has says. Now, obviously, if you're doing this in a doctor's office, it might be a little bit different. Okay, they might be a little bit more inclined to actually follow these rules. Okay, so your DEXA scan is basically an X-ray assessment. I don't know if any of you guys have ever seen a DEXA scan, but it's similar to an MRI. MRIs and DEXA scans can see the tissue density within your body. So they use large magnets. So if you guys have ever been in an MRI before because you've had an injury or something along those lines, if you actually lay in that machine, it is loud, super, super loud, and it takes a good 30 to 45 minutes depending on what you're trying to look at to get all those pictures in, okay? That loudness is those magnets that are working, okay? It's good because it gives you a direct measurement, but it's very expensive, okay? This is why a lot of people won't get MRIs or DEXA scans, okay, unless your insurance covers it, but it is accurate. The other thing is, we wouldn't be able to just go take a DEXA scan and you guys read everything. You have to have the training in order to be able to read a DEXA scan. Same thing goes for something like an MRI, and that is way outside of our training. But the DEXA scan is considered the gold standard of these assessments, okay? I know a lot of women, it can also look at your bone density. So a lot of women that have osteoporosis are required to go get DEXA scans so they can see the porosity of their bones, okay? So it can look for things like that, connective tissue damage, muscle strains, tears, those sort of things, but then it can also look at your fat-free mass and your fat mass as well, okay? Questions on DEXA scans at all? Okay. All right, bod pod is somewhat like the underwater weighing, except now you're not underwater. You are legitimately sitting in a machine that looks like a bod pod. So think like a little spaceship that you guys go in and close. So it's looking for air displacement, okay? So it measures your body density, okay? So it's gonna obviously measure your fat density, your fat-free mass density, okay? It's in a sealed container, but this is also expensive and accurate. The good thing about a bod pod is that it measures the same thing that underwater weighing would measure, but it's better for individuals that have a fear of water, or say an elderly individual or something, because this literally requires you sitting in a pod and then also just basically closing the door. You don't have to do anything. It is a small pod, so if you are claustrophobic, that might not be the best thing for you to do, but it doesn't take that long. I've never actually had it, but it'd be cool to actually try it. So I'll send you guys videos on all of these so we can somewhat more understand all the concepts of this, okay? All right, so nice short lecture today, not much to go over, okay? But I want you guys to concentrate on, make sure you guys look over this lecture again before Wednesday. to see if you guys have any sort of questions over what we were going to be going over. This Wednesday, we were going to be focusing on BMI and circumference, okay? And then next Monday, again, we will go over the calibers and the pinch test, okay? For any of you that just joined and you guys didn't hear me at first, okay? This Wednesday, we are going to be online again, okay? But we are basically going to be doing our lab and going over anything that we are confused on, and I can break it down for you more, and we'll have some videos that you can actually watch. Next Monday, we will be in class finishing our lab, okay? So just make sure you guys keep that in mind. Again, like I said, I will send you guys all updates on all this stuff, okay? If at any point you're confused on anything, just email me. And I should hopefully have your exams graded for you on Wednesday, so we can go over any questions that anybody has on that on Wednesday as well, okay? Any questions that anyone might have? I can tell it's Monday and everybody wants to get out of here. Okay, if you guys have no questions, I'll hang around. Otherwise, you guys can sign off, and I will see you guys all on Wednesday. All right, bye guys.
Is this a lab we can start now? Is it something we can start, or do we have to wait till Wednesday?
You guys have to wait till Wednesday because we're actually gonna have to do stuff this time.
Okay.
Right? Yeah, so but just if you haven't finished your other lab, just make sure you work on that and get that in.
Okay, thank you.
You're welcome.
Bye.
Bye.
Turn in the labs like on paper, like
Say
print
this
it out.
again, Kentrice.
Can we do the labs like on paper and turn it in, or it has to be submitted through online?
If you do turn it in on paper, totally fine. Just let me know that you've turned it in outside of my office at 3:31 so I can go pick it up, just because I'm not there all the time. So I won't be in this week, but just let me know that you've turned it in so I don't count you late. Okay? If that's what you're gonna do. Okay?